Practice homework 9.2, question 3. Find the loop currents y1t and y2t for t larger or equal to 0 in the circuit of figure A for the input ft in figure B. Okay, so figure B is like ft is 6ut. To solve this equation, try to find y1t and y2t first. Well, actually, we can just directly use the Kirchhoff's law to get two equations and to find solutions. However, in the time domain, we need to solve the differential equation, which is really hard. But if we use the Laplace transform, we don't need solve the differential equation anymore. It's just simply the multiply and divide, so it's much simpler. First, we write for the different circuits components in the Laplace transform. For the resistor, Vs equals to R times Is, and for the capacitor, Vs equals to 1 over Cs times Is, and for the inductor, Vs equals to Ls times Is. And we also know that for the dyt in the Laplace transform, we're gonna get sys minus y minus 0. And for the ft, which is 6ut, its Laplace transform is 6 over s, which is fs. And then we use Kirchhoff's law for these two loops. For the loop 1, we can get y1s times 2 omega here, and here, 2 omega plus 1h and s minus initial condition, which is y10, and minus y2s times 1 omega. And this equals to fs, which is 6 over s. And for the second loop, we do the similar thing, y2s times 2 omega plus 1h times s minus y20 minus y1s times 1 omega, and which is this part equals to 0 since there's no source. And then for the y1t, this initial y10, this initial condition is equals to f minus 0 over 1 ohm omega, and this 2 omega which is parallel connected, so it's gonna be 1 omega plus 1 omega parallel connected with another 1 omega. So which is, for here we can see is a 3, so is 3 volts over 1 plus 0.5 omega, which is equals to 2 ampere. And for the Y2 0 minus, and which is we can see it's half. It's a half. It's a half of the Y1 0 minus, so which is equals to 1 amp. And so we got these two equations and the initial conditions, so we can simplify the two equations. For the one, it's gonna becomes y1s 2 plus s minus 1 to y2s equals to 6 over s plus 2. And the second one is y2s 2 plus s and minus y1s equals to 1. So now let's calculate these two equations, and eventually we can get y1s equals to 2s squared plus 11s plus 12 over s times s plus 1 and s plus 3. So for y1 we can just write s capital A plus B s plus 1 plus c over s plus 3, and we use a carve up method. We can get A is equals to s1 s3 and 2s squared plus 11s plus 12. 1s equals to 0, so we cover up this one. After we calculate, we can get A equals to 4. And similarly for the B, we just 2 squared 11s plus 12 or s plus 1 and s plus 3, and 1s equals to minus 1, which cover up this one. So after calculation we get minus 1.5. Similarly C, we can get it's s minus 1 s plus 3. We cover up this one. After calculation we get minus 0.5. And for the y2s, we got the expression is s squared plus 4s plus 6 over s plus 1 and s plus 3. So similarly we just do some calculation, and we use our cover up method to calculate this. A is equal to 2, B equals to minus 1.5, and C equals to 0.5. So now y1 as we got 4 over s minus 1.5s and plus 1 and minus 0.5 over s plus 3, and we use inverse Laplace transform. We can get y1t equals to 4 minus 1.5 times e to negative t minus 0.5 times e to minus 3t, and this times ut. And for similarly for the y2s, a is 2, so 2 over s minus 1.5 plus 1 plus 0.5 over s plus 3. And we use inverse Fourier Laplace transform. We can get the pairs, different pairs from that table, and we can directly get, for this one is 2 minus 1.5 times e to minus t and plus 0.5 times e to minus 3t, and this part is times ut. Now we got the final